Hello YouTube viewers, welcome to my show Science Thursday. In today's episode we're going to continue our water series and today we're going to talk about water chlorination. So let's dive right into it. Now first thing you have to understand, water if untreated, if contaminated, is basically equivalent of bio bomb. Basically water is a universal solvent. You have to understand it. Water does not discriminate. You can mix lead into it, you can mix uranium into it, you can mix plutonium into it, you can mix basically cholera into it, you can mix dysentery into it, you can mix typhoid into it. It simply does not care. It will carry whatever can mix into it, which translates to almost every single thing. So that creates a problem, and that these three diseases are the big diseases, and there are hundreds of small diseases that can affect people and kill in hundreds to thousands of them. So you have to understand all those things combined, all those what we classify as waterborne illnesses. You can check the link of Wikipedia down below. Those kill people in millions, not 100, not 200, millions, as in like almost a small country worth of people is killed every year. And according to WHO in 2015, the confirmed death, not about infection or illness, that is in billions, but infection basically in terms of confirmed death, like you got infected by water, now you are dead, it's in upwards of 800,000 people per year. And it's fixed. It's like barely going down because we haven't figured out any proper way to do mass water treatment. So you have to understand it. Water is very dangerous if untreated. It's not a matter of luxury or choice or something like that. You will die if it's contaminated. So we have to take very serious precaution. So this brings us to the very crucial point. We need chlorination. Now, you think about chlorination, you think about modern water treatment, and that's absolutely true. However, you have to understand this technology goes back to upwards of 100 years. Now, in 1875, people started to figure it out. In 1890, some attempts were made. But in 1905, something big happened. Basically, typhoid epidemic hit basically Lincoln town in England. So a lot of people died and people needed some way to solve this quickly because like whole town could have been killed if it would have gone on continuously. So at that time they introduced chlorine water treatment and that stopped it. Like literally people went from dying hundreds of years and they're like, oh, people are safe here, people are living here, like, you know, not all our graves are completely full. So this is the first time large scale demonstration of chlorine was done. Basically, like chlorine is basically almost a fixed way, like you put chlorine, biological hoo-ha cannot touch you. So after seeing the success of basically this system installation in 1905, so USA is like in 1908 they also started experimenting it. By the time 1920 came along, almost all major cities had chlorination done into it. And this is a World Health Organization map from typhoid fever. Now you can understand red part is very contaminated, yellow part is like okay, but yellow also means there are not enough people there. So all these things combined, you can easily see USA is not there. Now USA is the third largest population country in the planet. So how the heck they are safe? Chlorination. This is what I'm trying to say. Like chlorine and biology, they do not mix. Basically, no matter which biological hoo-ha you have, basically from bacteria, protozoa to algae to some other things, it will not cross. Basically, water, contaminated water, chlorine, no biological accident can happen. It's almost like, it's not almost like, it is like ultraviolet. So this thing, and we've been using it for 1 century. It's not a small feat. Like if there is a technology that is time tested, this is one of them. This is why we use chlorine. So how do we utilize it in like actual municipality treatment? Now again, the description can go in long detail. I'm gonna simplify it in 3 simple stages. Now same way ozone is generally added to dirty water or quote unquote raw water, this is also done in the same way. How do we add chlorine? There are hundreds of ways. Sometimes liquid chlorine is used, sometimes gaseous chlorine is used, sometimes some agents are used which will become chlorine if added to water. So hundreds of ways are there and you can read a Wikipedia article in detail for that. So we basically add chlorine to raw water. Now why raw water? It does not suffer the same consequences as basically ultraviolet. Ultraviolet needs clean water. This on the other hand does not need it, and it also actually benefits from having a dirty water because once you have, let's say, iron, other things that it will break down, basically bacteria and virus and protozoa. It will also help in coagulation, same as what we call as ozone treatment. So coagulation will help you to filter out much more efficiently if you did it to raw water. So once you mix the chlorine, you have to allow it what we classify as contact time. Basically same as how in ultraviolet you have to have a radiation amount that it must be there, same goes for this. So contact time is very simple. You must let it bare minimum of 20 minutes of time so it can act, react, destroy and basically sterilize the water. Now Can you shrink that time? No. Can you increase the time? Absolutely. There won't be any side effect of it. Like people generally give a lot of basins are there where chlorine slowly mixes and stirs and does its job for more than 30 minutes or 50 minutes. Some places they take extra care, but you must not let it go down below 20 minutes. Then we remove the byproduct. This is critical aspect because chlorine creates a lot of byproduct by A, binding with other things, and B, by destroying a lot of biological matter. You must filter it out. Now this is the first stage of your municipality system. They put the chlorine breaks down everything and everything is filtered, and then after that primary filtration, then you remove the byproducts. Now byproducts could include basically heavy ions, ammonia and all that, because it does break down a lot of chemical things also. So it is a dual sword. Basically it can take care of biological contaminant and chemistry contaminants. It will not do anything about physics contaminant. That's the easiest to figure out. So that's why we use chlorine. It can take care of two things, basically two birds by one stone. So what is the problem? Why everybody hates chlorine? The moment you type chlorine, people like facts and myth, the cancer of this, cancer of that. Why the heck people hate it? Now first simple thing, it triggers our baser instinct. Basically taste and odor of chlorine water is bad, flat out it's bad. So it flat out triggers an emergency response in your body. It's like, dude, something is wrong with this water. Even though you could have a scenario where I give you one glass of contaminated water that is very sweet and one glass of treated water but it has chlorine odor, you will not basically try to drink chlorine water. Why? Because it stinks. It inherently is triggering a response in you that it is not safe. You will literally die by drinking contaminated water. So that is very baser thing. This is not something that we can go past by. Like this is fundamental. This is firmware level issue. Then it protects against reinfection. Now you might be like, okay, that's a good thing. Why the heck I have pointed that in red? That is the problem, because to do this, we generally add chlorine after the filtration process. After we have cleaned the water is absolutely safe for drinking, we reintroduce chlorine into it. So it can protect against a contamination during the plumbing system. Basically, if you have a pipe, and I'm talking large pipe system, basically, let's say you have a city water treatment plant and the pipe length is like 500-600 kilometers, you must make sure that it does not get recontaminated and does not have any contamination traveling backwards, bacteria, virus specifically. So adding chlorine makes sure that nothing can enter it. Now problem with that is if you put raw activated chlorine into the system, that means the byproducts will be also there. So byproducts are generally classified as disinfection byproducts, DBPS. Now you have to have specific filter for removing that, which was not done simply because they had to reintroduce chlorine in the water, which is active. They could not put disactivated chlorine. It wouldn't do anything. You have to have activated cover. Now this does protect the pipeline. It does make sure that even if, let's say, some tap is contaminated with let's say E. coli or anything like that, it won't travel backwards, because chlorine is like, you shall not pass. Now that also creates a side effect. It creates a lot of extra byproducts. That byproducts include THMS, very complicated name, that's why I'm not gonna say that, but basically this causes cancer. Then we have HAAS. This also causes a lot of issues, which includes brain deprivation, basically brain oxygen deprivation. The effect of this would be more or less like you are being drunk. So these two things are very dangerous. Now this is the part where things go from basically real science to voodoo science, is that people are treating chlorine as it's like guaranteed cancer. Here's the reason. The sole reason we've been using chlorine for 1 century is that we know for a fact that chlorine water will not kill you faster than any bacteria and virus. Simply the answer, the choice for every municipality is very simple. They put chlorine in your water and make sure it's biologically safe, aka you can drink it and you're not gonna die in 1 month, or then deal with the consequences that water is contaminated little bit, not too much but little bit, that over time goes for very long. For some people it will never have any side effect, or for some people it will trigger cancer reaction in 10 to 20 years. So what will they choose? Of course they will choose the chlorine, because 10-20 years is much better than dying in 2 years, and this does prevent against recontamination, which is very critical. You can filter the water as much as you want with ultraviolet, ozone and RO, but if recontamination occurred during the pipeline, or the whole pipeline can be contaminated, you may be sending as clean of a water as possible, but everybody would be getting infected by a disease or protozoa or things of that nature. So for this reason we have to use chlorine. Now what about the cancer risk? How real it is? Well, because we have been doing this for 1 century, there is serious guideline about this. Now if you are drinking chlorine water, basically you can flat out tell that it has chlorine, flat out tell it has basically a white color substance into it. Please use a filter. Now some places the once they re-add it, they add too much of it. So that scenario, please use a filter. Generally activated carbon filter will take care of you, but if you can't find that, use RO filter, but you please filter it out. You should not supposed to drink that. And if that is happening regularly, please contact your municipalities like, bro, you are adding too much chlorine. It's not supposed to be that much. And if you are doing treatment plant like right next to you, you can easily take care of the byproducts. You can remove the byproduct, and that at that case it will be perfectly safe. In pools, swimming pool, how many biological things are there? Like people are there, so you have to make sure their body is like literally contaminant carrier, so they have to make sure the chlorine is there. Otherwise the one infected kid could infect the whole theme park, so they have to use chlorine. So this is why we chlorine is like a dual-edged sword. We have to use it. There is nothing that comes even close to power of this. And basically long-term driving, basically you put chlorine, it's like, I'm here, I can take care of it at least for a few days. Now in terms of ozone, it's like, yeah, I'm here, I'm going to destroy everything and done. It's out. Like my job is done here, it goes away. So that means the reinfection can easily occur. Chlorine prevents that. That's why we use it. And in terms of cancer, what would you rather have? Typhoid, which is going to kill you in 1 week, or cancer that may kill you in 30 years, or maybe your body is flat rejects it, so simply you won't even get cancer. This is why there is a lot of problems with this. However, the primary trigger is that taste and odor. You will not know, you're not supposed to know whether the water has been treated by chlorine or not, because the recommended level is like 3 parts per million. That's milliliters of chlorine. Like you get more chlorine from salt. So you have to understand this. This is why, because it triggers our innate sensor, like something is wrong with this water. That is why we are so opposed from it. And not to mention, if you are swimming in chlorinated water swimming pool, your eyes will go red, your skin will turn reddish. It is a disinfectant, so basically it's disinfecting us, which means killing us or our skin cells. So what can we expect in the future? Now I told you, like time and time again, we simply have to use chlorine for reinfection protection. Now if you remove the pipeline and you are like, okay, we're gonna use bottled system, yes, you can bypass it, but unless you are doing that, there is no other alternative at this point in time. And in terms of any modern chemical additive that is like, better than that, no, flat out no. People have been trying hundreds of combinations, it simply does not even come close to effectiveness of chlorine. So there is no water alternative. Now in this whole video series that I'm talking about water treatments and all that, I keep referring to this core aspect. We do not have a magic bullet where you're like, okay, this is water treatment plant, this is one process that we do and done. Other than evaporation, there is nothing else. Like you inherently cannot do anything to water that's like, yeah, I'm gonna remove everything, biology, physics, chemistry, everything. You simply cannot do that. And on top of that, even if some magically you figured out to do that, you still have to reintroduce basically sodium or iron or calcium into the water, because distilled water is bad for us. So this is the reason why we introduce so many multiple stages of water treatment, because one contamination can like flat out kill a city. So chlorine is our best friend at this point in time. Now, is it the perfect? No, but what are you gonna do? Unless you start selling bottled water everywhere. So this was my presentation. I hope you liked it, learned from it. In that case, please leave a like button, and if you didn't like it, don't worry about it, you can press dislike button. I would urge you to press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.